Well, howdy, folks. How we all doing today? Good to see you guys. Yeah, I know you guys got a long video last time, and I'm sad that I got one more long one probably for you today. Again, we're just making up for the things we missed during COVID last year. So we have to go in a little bit more depth. I got to give you a little bit more extra practice on things. So that being said, we're going to make sure that we're all taken care of. We got everything under control here as we move on. So we're going to be talking more about polynomial functions. The first thing we talk about is long division. Now, when you think of long division, you probably think of something like this, right? 219, something like that. Let's go 229. That sounds more fun. All right, in long division, the first thing you always do on long division is you figure out how many times your number goes in here. So 7 goes into 22 3 times. Then you multiply it, and then you subtract it. Then if you got anything left over, you bring it down like that. And you ask yourself, how many times does your number go into that? And we did this back in, probably 4th grade, maybe 5th grade. So we get, whoopsie, let's make that a different color. Let's make that purple. So we get the 2 times 7 is 14. And then when you get done subtracting, if you have a number left over, because there's no other number to bring down, we said you can either write it as a remainder 5, or what we eventually do is we start taking that remainder and putting it over the number we were dividing by. Well, it turns out polynomials can be divided the same way. So we're gonna divide a little bit, and then after that we're gonna talk about a couple other ways that we can divide this as well. So to begin with, we're gonna go ahead here. We got 4x cubed minus 7x squared minus 11x plus 5. And again, we're going to be covering the rest of pretty much we do pretty much polynomials in 3 days, all the polynomials you would have done in integrated 3. So again, we're going to go into a little bit more detail. But here's how polynomial division works. I'm always going to take this term and I'm going to ask myself, how many times, or what do I have to multiply the 4x by to be equal to my leading term? So in this case, what do I have to multiply 4x by to get 4x cubed? And you guys would say, because you guys are the brilliant math students you are, 4x times x squared. So just like we did with the numbers, I'm going to take that x squared and I'm going to multiply it by the 4x, and I'm going to multiply it by the 5. And then just like the numbers, after we multiply, we always subtract. So we are going to subtract. And let's see here, we get the 4x cubed minus 4x cubed goes away. Negative 7x squared minus positive 5x would be a negative 12x squared. And then we bring our next term down. So we're going to bring the next term down. Just like we did with numbers, it's just now we're doing it with variables. So now we sit there and we look at it, 4x times what would be negative 12x squared? You guys would say negative 3x. Now we get a negative 12x squared, because 4x times negative 3 is negative 12x. Squared. Negative 3x times positive 5 would be a negative 15x. Again, once we multiply the 4x plus 5 times negative 3, now we subtract it, just like we did with the numbers. And we end up with, what do we end up with here? We end up with 4x. And I'm going to run out of room here, which is never good, but is what it is. We get a bring down our next one, we bring down our positive 5. And this time, 4x plus 5 times what? So I'm looking at 4x times what number would give me 4x? Well, that's just going to be 1. And we do our polynomial. This is called polynomial long division. Now, for us, we're not really going to be dividing this way. We're going to use one of a couple different ways here. And when I divide, my remainder is 0. So this number, since I have no other numbers left to bring down, whatever this number is, that would be my remainder. So we have a theorem that says if there is no remainder, in other words, if the remainder is 0, then it is a factor. A factor meaning it divides equally into the function. So remainder equals 0. In other words, 4x plus 5 is a remainder of this polynomial. Now, friends, that's one way that we could actually divide. Here's the other way you would have learned back in integrated 3. Let me show it to you here. And maybe you guys got this far. I don't think you did. I think you guys went out on break. Or not break. I think you guys went out on the semester too early where you weren't able to get to it. Don't worry about it, friends. So here's how another way to divide. We know that if I multiply this 4x plus 5, so I'm going to bring this 4x plus 5. If I multiply it by some other term, I should be able to get something in the box that is equal to 4x cubed minus 7x squared minus 11x plus 5. So we're going to multiply this way. So first of all, I'm going to try to multiply by 4x plus 5. So you can do polynomial long division if you want to, but if you don't want to, no worries. And I'm going to try to somehow multiply it where I get the 4x cubed minus 7x squared minus 11x plus 5. So that means if I were to multiply it, the first term always goes in the top box here. So that means my 4x cubed would have been in the top left, although that should have been a cube there. And then my positive 5, if I were to multiply this out using a generic rectangle, it would have been in the bottom right. And I don't know if you guys noticed this or not, but this diagonal of rows always gave us that second term, that in this case, the negative 7x squared term. And this diagonal rows right here, well, that was horrible. Let's try that again. There we go. Always gave us the next term, in this case, the second to last term, the negative 11x. So knowing that, I think I'm going to be able to actually go through here and potentially figure out, using generic rectangles, how to actually go about and clean this up. So this, I'm going to make these arrows a little bit shorter so I know what I'm looking at here. There we go. All right, so we go through here. 4x times what is 4x cubed? And you guys would have told me, well, that would have been x squared. So if I finish off my generic rectangle here, I get x squared times 5 is a positive 5x squared. But then I know that the positive 5x squared plus this rectangle has to be equal up to negative 7x squared. So in order for that to happen, this would have had to have been negative 12x squared. Now they equal negative 7x squared, the number on the outside. So if that's the case, 4x times a negative 3x would have worked. And as I keep going down here a little bit, I would end up with a negative 15x. Well, I know that this term plus this term have to be equal to the negative 11x. Just like I knew that the positive 5x squared in this missing term had to be the negative 7x squared. So in order for this to work, that means this would have had to have been a positive 4x. And lo and behold, friends, therefore I end up with a positive 1. Now, just as the sake of argument, say this number right here was a positive 3. It's not, but say it was a positive 3. So when I multiply this positive 5 and positive 1, I would have realized, ooh, I'm not big enough. I'd have to add 2 more. And that would have became then my remainder of having 2 more that I had to add. Or another way to think of it, say it's not, but think if this number was, say, a positive 7. Well, 5 times 1 is 5. I would have had to have taken away a negative 2. Therefore, my remainder would have been a negative 2. But in this case that I'm dealing with on this problem, that last term that I had in my polynomial was a positive 5. So when I multiply my positive 5, my positive 1, I realize I got the actual number that I'm looking for here. Therefore, I have no remainder. My remainder then was 0 since there's nothing left over, and it was a factor. So what I want you guys to do here is I want you to go ahead and take a second here. I would like for you guys to go ahead and do some practice division for me. Okay? So I'm going to have you guys go ahead and start off. I would like you to divide 2x plus 1. And you can do polynomial long division, or you can do generic rectangles. Just so you're aware, I'm going to end up using the generic rectangle. Okay? So 2x cubed minus 3 minus 9x squared plus 7x plus 6. So I'd like for you guys to go ahead and divide that one, okay? And then you'll tell me what it equals. And then also, when you get done with that one, for the really astute math student, let's try this one. X squared minus 3x minus 4 divided by x plus 3. All right, go ahead and pause the video and see if you guys can try that real quick. Why don't you guys go ahead and do some polynomial long division. All righty, so you guys got a chance to try it. Let's see here, see if I can kind of catch up with you here. And again, this term right here, that's not what I wanted, wrong shape. This term right here, that's going to become what I'm going to divide by. And these two terms right here, I'm going to try to divide into it. So the 2x cubed and the positive 6, they'd go here and here. This first rectangle is going to be equal to the negative 9x squared up above. And then the positive 7x would be equal to this diagonal right here. And I'm trying to figure out what the value is when I divide, including do I have a remainder? Okay, so let's try it. All right, let's see. I need an x squared again here. So when I multiply it out, that makes this a positive x squared. Well, I have a negative 9 here. I have a positive 1 here. Therefore, this one would have to be a negative 10x squared, which would then make this a negative 5. So we keep going, friends. When I multiply out the box, that makes this a negative 5. So I got to say, all right, what number plus negative 5? What number plus the negative 5 is going to give me a positive 7? Well, that would be a positive 12. And therefore, then that's a positive 6. And that positive 1 times positive 6 is positive 6, so I have no remainder. So that means when I divide these together, 2x cubed minus 9x squared plus 7x plus 6. When I divide those by 2x plus 1, I had a remainder of 0, which means it's a factor. And what I had left was x squared minus 5x plus 6. Just going to erase a little bit to make it a little easier for me to read. Whoopsies. Did not mean to do that, though. I tell you what, that was a, oh, what was that? That was a minus 12. And I am so sorry, guys. I meant to make this an x cubed. So I know you're probably upset with me. Makes you feel better. I'm upset myself. The reason why I wanted the x cubed there, not the x squared, is if we're missing a term, in this case, if I'm missing a x squared term, I have to go through and add in the missing term. In this case, it would be a 0x squared. So if I'm missing a term, don't worry about it. Just add a 0 in as a placeholder to do it. All right, so friends, now go ahead and pause the video. First of all, because, well, I made a mistake. But second of all, try to see if it will divide in now with that placeholder. All right, let's see what you guys came up with here. If I were to divide it in there, whoop, whoop, whoop. Again, this is called we're doing a type of polynomial long division, but this time we're doing it with a generic rectangle. And as you guys are noticing, I'm pretty much staying away from doing it the old way of like we learned back in 5th grade with the numbers, because this works just as fine. So I need an x squared. And then what do I have here? I have a positive 3x squared. And if you notice, I need this row again to be a positive 0x squared. That's where that placeholder comes into play. And I need this one right here to be a negative 3x. So, all right, we got our 3x squared here. That means the missing term is a negative 3x squared. That's how I get my 0. And we have a negative 3x. So therefore, I'm going to end up with a negative 9x here. That we get there? Yeah, it looks like a negative 9x. No harm, no foul. And if I'm looking for a negative 3, we'll go right here. Got to make that a positive 6 there. So x cubed. Okay. And then we have 3x squared, negative 3x squared. Splendid. All right. And then next thing we have here, we got our, that gave us our 0. So then we have our negative 3 times positive 3 is negative 9x. In order to get our negative 3x, we had to add a positive 6. And last and certainly least, friends, that means I need a positive 6 here. But notice, when I multiplied these together, I needed a positive 18 here. 3 times 6 is a positive 18. So in order for me to turn that into a negative 12, I needed a positive 18. I would have needed to subtract 30 from it to get my negative 12. So that means I actually am going to have a remainder on this problem. That remainder would be a negative 30. By the way, since there's a remainder, that means I do not have, this is not a factor. I'm going to add a x plus 3 like that. So that, if I were to divide these two together, that would be what I have left over. Now, friends, we have another type of thing called synthetic division. And I'm going to take this same idea here, this problem of x cubed plus 0x squared minus 3x minus 12. So here's what synthetic division does. All right, and this is the last type we have here. So we have this x plus 3. Synthetic division says, hey, let's assume that was a root or a 0. So if I were to do that, I get x equals negative 3. This is also called synthetic substitution. Synthetic substitution allows us another way to divide that is more algorithmic. And what it tells us I'm going to do is, as I go through and do this problem, I'm going to add always, always, always going down. And then going up, I'm always going to multiply by whatever number is in the box. And in this case, the number in the box is a negative 3. So I'm going to multiply by whatever number is in the box. So here's how this works. This synthetic division says, if we were to take every coefficient and line them up. So I'd have a 1, I'd have a 0, I'd have a negative 3, and a negative 12. I were to just line them all up, just one after another, line them all up. This says I can potentially divide using this algorithm and it'll work. Now, I'm going to add going down. Notice there's no number going down, so I'll just go ahead and put a 1 there. There's no number going down. So 1 plus 0 is 1. And then I multiply by the box going up. So 1 times negative 3 is negative 3. I'm going to add going down. 0 plus negative 3 is negative 3. And then I'm going to multiply by the box going up. So negative 3 times negative 3, that would be a positive 9. I'm going to add going down. So negative 3 plus 9 is 6. And then I'm going to multiply by the box going up. 6 times negative 3, I get a negative 18. And I add going down, get my negative 30. In case you noticed, we have a 1, we have a negative 3, we have a positive 6, we have a negative 30. So if I started with a factor of x, and I'm dividing into an x cubed, that means I'm going to reduce it by 1. So I'm going from x cubed down to an x squared minus 3x plus 6 plus a negative 30 divided by x plus 3. This idea of synthetic division is really, really, really a slick idea. It allows us to divide really quickly without having to go through polynomial long division or without having to go through one of these generic boxes. Now you still can if you want to, but it takes a little bit more time. So here's what I want you guys to do. I want you to go ahead and see if you can divide using synthetic division this time for that one. Okay, so that one right there. While you're doing that, I'm going to erase here. So pause it while I erase, and we'll do it. All right, I'm going to leave the rest of that for the time being, so we can refer back to if we need to. So that means my factor here, I got to start with my factor. So I'm starting with x minus 3. So to figure out what number goes in the box, I'm going to set that equal to 0. So x minus 3 equals 0. That means x equals 3. So I'm going to plug 3 into the box. And then notice I'm missing a term. So I'm going to add a 0x cubed By the way, I have a 1 in front of there. Minus 10x squared minus 2x plus 4. So we added our placeholder, and I'm going to take each of these coefficients, 1, positive 0, negative 10, negative 2, positive 4. And those are going to be the numbers that I carry over here to do my synthetic division, to divide. Now, when I'm dividing, I'll be honest, friends, if it's a linear factor like this, I always use synthetic. I just do it. It's quick. Remember, I'm going to add going down. So there's no number to add by here at the beginning. I'm going to add a placeholder. So 1. And then I'm going to multiply by the box going up. And this time, the box isn't negative 3. This time it's positive. So 1 times 3 is 3. Add going down, 0 plus 3 is 3. 3 times 3 is 9. I multiply by the box going diagonally up. Add going down. I'm going to multiply by the box going up. So negative 1 times 3 is 3. Add going down 1. And I multiply by the box going up. So 1 times 3 would be 3. So we have 1. We had a 0, negative 10, negative 2, 4. So 1, 3, 3, 9, negative 1. Oops, I didn't do my writing. Read that correctly, did I? Got to fix that. I know you guys are probably yelling at the screen. Williams, you forgot a negative. Yeah, I did. Negative 2, negative 3. That'd be a negative 5. That's a little bit better. 3 times negative 5 is negative 15, and I end up with a negative 11. So we were at an exponent of 4, which means that this is going to be an exponent of 3. 3 plus 3x squared minus 1x minus 5 plus negative 11. I had a remainder, x minus 3. In other words, I got x cubed. When I divided, I got x cubed plus 3x squared minus 1x, so minus x, minus 5 plus a negative 11 over x minus 3. So if I were to divide those two together, if I would have divided f of x by x minus 3, this is what I would have got. All right, so clear, boom. So you would have done all that in one day and integrated 3. And the reason why we need that is because, what if I give you 2 factors? 2 factors and I ask you to divide. What would that look like? Okay. So in other words, what I'm looking for 2 things here. First of all, I want to know what the zeros are for this problem. And then don't worry about the prime factorization. We'll deal with that in a second. So I told you what 2 of these are. I told you that these 2 are going to be zeros. See what you can do with that. Okay? See what you can do with that. Set, off you go. Go and pause the video. All right, friends, you're back here. So you guys, if I told you that x minus 2 is a factor, that means x equals 2 is a root. If I told you that x plus 3 is a factor, that means x equals a negative 3. We are going to do our synthetic division. So what are we dividing into, you ask? We're going to divide into 2, positive 7, negative 4. And you guys already did this. I'm just checking your work here. So what you guys found out by this, by finding the 4 zeros, is you're able to actually figure out all the zeros and thus what all the x-intercepts are. If you know a couple of them, you can figure out the rest of them without having to actually do any sort of graph and calculate or anything. You can just go through and calculate it. So 2 plus 0 is 2, multiply by the box. 2 times 2 is 4. 7 plus 4 is 11. 22. Oh, we're getting big numbers. 18. There's some we can use called upper and lower bounds. They don't really do a lot for you. So we're kind of ignoring them here. 18, and we end up with 0. So notice, I took x minus 2, I divided into a quartic, and I ended up with a cubic. That means that x equals negative 3 would have to go into this cubic. So friends, I'm not going to be starting over with the same one. I'm going to take the result I just got there. That's going to be what I'm going to divide negative 3 into. So we got 2, we have 11, we have 18, we have 9, and I'm going to divide my 2 into that one. So, all righty, placeholder, add going down, 2, multiply by the box going up, negative 6, 5, negative 15, 3, negative 9, and we end up with 0. Again, I have another factor, which they told us it was. Realize this is 2x squared plus 5x plus 3. So if I want to find the remaining roots, factor it. And you guys did this. Maybe you did the quadratic formula. That works too. So 2x plus 3, x plus 1. So that means x equals a negative 3/2. And x equals a negative 1. So a fourth polynomial, a fourth root polynomial, notice it had 4 zeros. That's an interesting idea. We'll come back to that at a later time. Now the next part, the last part of that is to write the prime factorization. In other words, what they mean by that is this. Okay, so we had 2 of the roots. Notice I have 2 more roots, or 2 more factors here. Although, I did forget a parenthesis. So notice I have 4 factors. So if I'm writing it as a prime factorization, that means literally just take all the factors and write them in place. So f of x equals the 2 that they gave me, x minus 2, x plus 3, 2x plus 3, and x plus 1. All right, friends. So let's have you guys try one here just for the fun of it. I'm going to give you the function. I want you to show, try this instead. Show x minus 4 is a factor of, find all the remaining roots. So what if I give you another one here? Let's let f of x be 3x cubed minus 10x squared minus 16x plus 32. All right, friends. I gave you one root. You go find the other ones. Pause the video and go for it. All right, welcome back, friends. So here's our factor we're dealing with. We know that's our factor. So x minus 4, I got to figure out what number goes in the box. So I take it, set equal to 0, x equals 4. So that goes in my box. From there, I got to figure out my coefficients. I got a positive 3. I got a negative 10. I got a negative 16, and I got a positive 32. So that's what I'm going to write out here. So 3, negative 10, negative 16, positive 32. Whoop. There we are. All right, placeholder. Need a placeholder. Let's use 0 the hero. Add going down, multiply by the box going up. So 3. 3 times 4 is 12. Add going down, 2. Multiply by the box going up. 4 times 2 is 8. Add going down, what do we have there? Negative 8. Uh-oh. 3, negative 10, negative 16, positive 32. Well, what one did I make a mistake on? Oh, 3x squared plus. Oh, yeah, that would do it. Yeah, that did it, didn't it? Oh, man. Let's see here. Add going down. Oh, no, we're good. I lost my head there for a second. Negative 32. Yeah, friends. That's what I get for doing math on the weekends, right? There we go. All right. You're like, just finish the problem, Williams. I'm getting there. So 3x squared plus 2x minus 8. Notice it goes in evenly. So to find my roots, 3x squared plus 2x minus 8. And you guys are going to factor. So box and diamond, maybe use a quadratic formula, whatever works for you. Does not matter. You guys can take your pick. Oh, let's see here. Make that a 4. And we'll make this a minus 2 plus 2. So 3x minus 4x plus 2 is what you should have came up with. And friends, that means that x is equal to 4/3. And x equals negative 2. And there we have it, friends. We have all of our 3 roots. X equals 4. X equals 4/3. All right. So we're cruising on here a little bit longer. Why don't you guys go ahead and try dividing here a little bit. All right, good luck with that. All right, go ahead and pause the video. Even though it's a fraction, it will not hurt you. Set and go for it. All right, now that you guys are done, so you had negative 1/2 in the box. And again, you got that by setting this equal to 0 and solving. So what will our coefficients be? 4, positive 16, negative 23, negative 15. We got a 0, and we are adding going down. Multiply by the box going up. You just keep doing the same thing, friends. 14. We have a negative 7. We got a negative 30. We got a positive 15. And we have 0. Hey, by the way, just for the fun of it, if I were to go through, that would have been an x squared. I want you guys to see something here. If I were to ever ask you to, on something like this, where the fraction was in the factor, if if I were to ever ask you guys to go ahead and try something here and write the prime factorization of this, we wouldn't want to have 1/2 in the factor as one of our factors. But if you notice here, what do all these numbers have in common? Yeah, you guys should hopefully see that they all have 2 in common. I can pull out a positive 2 out of that. That would have left me with a 2x squared. And again, you don't have to do this. I just want to show you something real quick. 7x minus 15. So when I go ahead and I multiply it, I have x plus 1/2 times 2 times 2x squared plus 7x minus 15. What if I were to take that 2 and multiply it into both these terms here? We could do that. Multiplication doesn't matter. And if I were to do that, notice the x here would have became a 2x. I would have got it back to being some sort of prime factorization here. We really don't want to have fractions in our factors. If we do have a fraction in our factor, we really want to try to go ahead. It means you're going to be able to factor that denominator out of that fraction, out of another term. In other words, this 2 that was in my denominator meant I was going to be able to factor it out of the other term. And I can distribute it out. So if I ever ask you to do a prime factorization, make sure there's no factors actually in your factors themselves. No fractions in our factors. All right, rational root tests. Well, this is kind of a cool idea here. And I'm going to show you another example as we go through this so you can kind of see what we're looking at. So right here, the notes, looks like Miss Hodge gave you guys an f of x. I'm going to give you guys a g of x. Okay. And I want you to kind of see where we're going with this so that way we can talk it through. She's given us a great example to follow. Let's see if we can't figure out another one here. Let me make sure I write it down correctly. I already wrote a couple of these off a little bit. 2x cubed plus 7. Seriously, I am struggling with 2's and 3's. Let's make that a little bit bigger. Maybe that'll help. All right, we got 2x cubed. That did help a little bit, didn't it? Plus 7x squared minus 2x minus 15. All right. So what if I give you no fractions or no answers whatsoever, and I ask for you guys to determine what the actual rational roots, in other words, what roots that could be written as a ratio or a fraction, if I ask you to find them? Well, here's what this thing says. It says all the factors of p divided by all the factors of q. And right now you should be going, what the heck are p and q? It's okay, we got it. P, wrong color. P is the last number, okay? So P is always going to be all the factors of our last number. And again, this is a crazy little theorem. It was really cool back before we had graphing calculators because it helped us break down an infinite number of possibilities down to a handful that we could actually deal with. Q is all the factors of our leading coefficient. In other words, all the factors then are going to take the form of all our p's, all the factors of our p value, divided by all the factors of our q value. And some of you are going, that's still a lot. Yeah, but it's a whole lot better than infinity. So take a look at this one. What I want you guys to do is our extra example here, I want you to write all the factors of p, and I want you to write all the factors of q. And then we're going to write them as p over q. So all the factors of p. In other words, what are all the factors of our constant number? So I have a negative 15. What are all the factors of q? In other words, what's all the factors of 2? All right, here we go. Pete, since it's 15, that could be plus or minus 1, plus or minus 2, plus or minus 3. Oh, you should have stopped me. There's no 2. Come on now. Plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So we have 4 different numbers that go into 15. For q, we had plus or minus 1 and plus or minus 2. So here's our q, and here's our p. All the factors of the last number, all the factors of the first number. So all of the possible rational roots will be all of our p's. So 1 over 1, 3 over 1, 5 over 1, 15 over 1, and then we have 1 over 2, 3 over 2, 5 over 2. And guys, I don't think you're going to understand how big a deal this was for mathematicians. Because up until this point, again, we didn't have graphing calculators. So we had an infinite number of possibilities. And 2, 4, 6, 8. And from that infinite number of possibilities, this theorem let us cut it down from an infinite number of possibilities down to 16. Friends, anytime you can cut an infinity down to 16, that's a big cut down. That is better than a needle in a haystack. So now we will go through and we will do the p over q thing. So we're going to take all our coefficients of g of x. And since p over q is pretty quick, we're going to just start trying one after another until we find one that works. So we're going to go one after another. So maybe I try, be systematic. I'd always try like 1 and -1. Here's a little hint about 1 though. Add up all your coefficients. If all your coefficients add up to 0, then 1 will work. So 2 and 7 is 9, plus -2 is 7, plus -15 is -8. I know that 1's not going to work, but we could try -1. So we try it, and we're looking to see, does it go in? It may not. If it doesn't go in, no harm, no foul. We'll just try another one. All right, we'll just try another one. If it doesn't go in, we don't have to worry about it. We'll just try another one. So -1 didn't go in. That's okay. Doesn't matter. We'll just try another one. And you're like, you got to be kidding me. Well, guys, go ahead and use your graphing calculators to help you, quote unquote, choose appropriately what number you want to try. So maybe I try 3. I'm going to try -3. Use your graphing calculator, you'll probably see why. So 2, plug -6, 1, what's that? A -3, -5, and then 15. And lo and behold, 0. I went from a cubic down to a quadratic. And so that's what happened here. She went from a cubic down to a quadratic. She found one that worked. Notice my remainder was 0, so it was a factor. This one was -8, wasn't a factor. So I now know for me that one of my roots, one of my zeros, was -3. On her example over here, she knew that it was equal to 2 because it had a remainder of 0. But best part about this is once I go from a cubic, I'm now down to a quadratic. So friends, I could try to factor it. I could use the quadratic formula. I could use completing the square. It's really on you. I'll use quadratic formula. So x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. The negative b plus or minus the square root minus 4 times a times c. I was going to write an a there. I don't want an a. 4 times 2 times c all over 2a, so all over 4. So x equals -1 plus or minus, oh, what's that going to be? Square root of 41? All over 4. There are my other two zeros. So x equals, now I have all three of my zeros, and I am sitting pretty. And again, what you guys hopefully are noticing is the degree of our polynomial is somehow tied into our, how many zeros we're going to have. Now, you might be making some ideas here that you have. They're not absolutes. We'll talk about why they're not absolutes here in a couple days. But notice, whatever my degree is, in this case, my degree was 3. I won't have any more than that many real roots. All right, friends. Well, let's have you guys try one here, shall we? All righty. Go for it. All right, rational root theorem like there is no tomorrow. Go for it. See if you can solve it. Start off with your PU over Qs. Go ahead and pause the video and we'll talk. All right, well, welcome back, friends. Welcome back. Looks like I got my P's and Q's here. So my P's are all these numbers. My Q's are all these numbers. Whew. Oh my goodness, friends. And you guys probably saw that there were a lot of P's and Q's, right? So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and our Q values. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 8 or 6. And you guys are probably, if you're thinking this through, you're going, wait a minute, this isn't much of a cut down. Well, again, you got to remember we're cutting down from infinity, right? Cutting down from infinity. So yeah, it is a cut down. Maybe not as much as you want it to be, but it is a cut down nonetheless. I meant to make that a 4. All right, so there's all my p-values over 1. Now I do all my p-values over 2. And bear with, I will go as fast as I can here. These are a lot of fractions I'm writing. Writing this many fractions with a mouse, not fun. Okay, so then we have all our p-values over 3 now. Holy wow. 1 over 3. All right, now I'm starting to feel for you. Yeah, because I got to write a lot of these two here. 2 over 3. All right, how about 4 over 3? 8 over 3. And then lastly, all the p-values over 6. Wow, friends, wow. So 1, 6. All right, so you can say it. We cut down what looks like to 32. So infinity down to 32. Maybe we actually did a little bit better than that. Let's see here. We'll find out in a second. I think we actually did a little bit better than 32. But even if it was 32, infinity broken down by 32 is still a good number. Let's see what we got here. 1, 2, 3, 4, 8, 1/2. Notice 2 over 2, well, that's 1. That's cut down. 4 is 2, already had that one. So we do have some duplicates. So, I mean, it's a little bit better, right? 1/3, 2/3, 4/3. Well, I mean, there's still a lot, but we cut down from infinity down to 20 choices. All right, well, I mean, wish it could be better, can't be. So we're just going to go ahead and pick one. I know that 1 is not going to go in. So I'm going to just pick a number at random. Oh, if only I knew what number to pick at random. Chances are I do. I'm going to go with a -2. All right, so we have 6, 25, 26, -4, -8, and we'll put this over 0 as a placeholder, and we are just going to add straight down. So 6, -12, 13, -26. Well, that's not fun. We got a 0 there. Oh well. We got a 0, we got a -4, 8, and 0. So -2 works. That's good stuff. So I went from a fourth, a quartic, down to a cubic. That was an x squared plus 0x. We leave that. So that'll be the numbers I use for my next one. So I have a 6, 13, 0. And again, I'm not going to go all the way back to the original. I'm now at a quartic or a cubic. I'm trying to get to a quadratic. By the way, take a look at this real quick. My last number is -4. One of my original factors no longer goes into -4. 8 no longer goes into -4. So I can get rid of these ones then. I know those no longer work. They worked in the original when I had -2, but they don't work here. Now, sneaky, just because I use this -2 one time, it doesn't mean that it doesn't go in again. Rule of thumb, don't neglect or don't forget, not a rule of thumb, more of a suggestion, don't forget to try it again. Because remember, I could have multiplicity in my roots as well. So don't forget to try, if I find one that works on a quartic or a fifth power or whatever, don't forget to try it again. It may work again. 6, -12, 1, -2, -2, 4, and in this case, notice, -2 worked again. That's okay. This means I have a multiplicity. And again, I have another remainder that's 0. Therefore, it is a factor. Now I can use the quadratic formula, complete the square, or factor to solve it. So I don't know what you guys did, but I am going to factor. So I got 2x. Oh, let's try a -1 there. And how about a 3x plus 2? So x is 1/2. And x is -2/3. So if I'm asking for my zeros, which I am, I would have first said x is 1/2. X is -2/3. But I also would have said x equals -2. Now I'm not going to write it twice. I'm going to go back and talk about multiplicity. Multiplicity, it came up twice. So I'm going to write that it had multiplicity. Multiplicity of 2. And at this point in time, I'm going to show you guys a word problem. Don't worry too much about it, but just so we have a little idea, these things can come up. They do show up from time to time. The idea of, they do give you a definition in here. So take a second, pause the video, read it real quick, and then we'll talk about it. All right, well, here's what they told you, girth. And for girth, for those that don't know what girth is, they give you a definition. It's the perimeter of a cross section. All right. So girth, the perimeter of our cross section is 4x. Notice we have our x's here. That means the girth is x, 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 and x. So our girth, the perimeter of the cross section, would be 4x. So what they say, it says a rectangular package sent by a delivery surface can have a maximum combined length. So maximum combined length of 100 and girth. So combined of those two of 120 inches. All right. So real quickly, just before I start getting too far, I'm talking about maximum combined length of girth, and altogether they equal 120. So I do know that I have some sort of combined length. So combined means addition. So find the length of y, the length, and the girth, which was 4x. And that's going to somehow equal 120. All righty, so here we go. So that the volume of the package is given by this. All right, we can do that real quick. Volume of the package, so V of x. So length times width times height. Well, the length and the width, that's a square, so x times x, which is x squared. And the height was y. Well, I don't really want to have y because I want everything in terms of x. So y is 120 minus 4x. So x squared times 4x minus, 120 minus 4x. Sorry about that. Well, that's not quite what they wanted. They wanted this. So let's just go ahead and factor a little bit. See if we can't get that. So we have x squared times, if we factor out a 4, I'm left with 30 minus x. And hey, that works out pretty good. So it really does. 4x squared times 30 minus x. All right, part B says, use a graphing utility to approximate the dimensions of the package. All right, well, I'm going to show you what the graph's going to look like, but at this point in time, you're going to have to do this on your own here. All righty, it looks something kind of like this, friends. Kind of like this. So it's going to come down here. These are negative x values. Can't have negative x values, but it's going to bounce. I know it's going to bounce because x squared, 0, is an x-intercept. So 0 is an x-intercept, and it has a multiplicity of 2. By the way, my other x-intercept is 30. So when you guys do your bounds, I'd probably close off my window. And then from there, I get a wonderful value. And then here at 30, I cross over. By the way, I'm dealing with a graph that's going to look like this. So between 0, I have an x-intercept. Between 30, I have an x-intercept. And for those of you that want to know, you do the maximum value on your graphing calculator, and you're going to come up with a maximum value at 20. It turns out at 20, it has a maximum value of 16,000. And if x is 20, or in this case, if x is 20 inches, then y is going to be 120 minus 4 times 20, which would be 80. 120 minus 80 would be 40 inches. And friends, that means the maximum volume would be at, or v of 20 actually. That's what I should have said. V of 20, the maximum volume will be located at 16,000 inches cubed. And it says, find the values of x for when the volume is 13,500. So if I were to draw a horizontal line, I would use the intersect function of my graph to figure out where these are. Notice, there's two values that are going to work great for me. Two values would have worked great. These values would have been at when x was 15. So x equals 15 here. And the other value would have been at right here where x is 24.25. 255. So the two values of x that are good those would have been at x equals 15 and x equals 24.255. That's when the volume is 13,500. And alrighty, last one. I told you this, guys, this was going to be a little bit longer, but luckily we're coming down to the end. Notice this volume, this x value here would have been bad. Reason why it would have been bad? Oh, we would have had a negative x value. Not bad, bad. Can't have a negative length. So the bad one would have been at negative when x was negative 9.271. So again, you use the intersect button on your calculator, and you would have found out that we do have a negative value, and that's when that graph crosses over there in quadrant 2. So, all right, friends, that takes care of our second and really long one. After this, we'll go back to normal length. Yay! So good luck. We'll see you in the morning.